Hi guys, it's week 12. We're going to jump in. We have lessons 108 and 109, and then 110 on the next day, on Thursday. So 3 lessons to get through this week. All right, so looking at lesson 108, we have similar solids. So solid meaning 3-dimensional, and again, similar, just like with polygons, they're going to have dimensions that are proportional. If they're identical, then they're congruent. But similar means they're going to be same shape, and then the side lengths, the height, whatever we're looking at shape-wise, are going to be proportional. So again, looking at similar from a diameter of 4, height of 3. If we double it, we go 8 for our diameter and a height of 6. Looking at these two, they are not similar because, well, 4 times 2 equals 8. 3 times 2 does not equal 4. So they are not similar figures. And we can use what we've learned about cross products to pretty easily identify if they are. So 4 over 3, or you flip it 3 over 4, doesn't matter, equals 8 over 6. We cross multiply. Okay. 4 times 6 is 24. 3 times 8 is also 24, so they equal. As we look at 4 over 3 and 8 over 4, 4 times 4 is 16, 8 times 2 is 24, so those are not equal. Similar to what we talked about in the scale factor when we're talking about perimeter areas and volumes, we can apply this. We also can apply this relationship of scale factors to area movement. So the ratio of the dimensions are going to go up by the scale factor, the ratio of the surface areas go up by scale factor squared, and the ratio of the volumes are going to go up by scale factor to the power of 3. So we talked about this just a few days ago. We know that if it's a perimeter or just a distance, one-dimensional, looking at scale factor. If it's 2-dimensional, be it area, lateral surface area, total surface area, it's going to be scale factor squared. And then if it's a volume, 3-dimensional, then it's going to be the scale factor, whatever that is, raised to the power of 3. Okay, so let's look at an example. An architect builds a scale model of a building she is designing. The scale is 1 inch equals 5 feet. So every inch of the scale model would be equivalent to 5 feet of the actual. Okay. What is the scale factor from the model to the building? Well, we would want to convert 5 feet to inches, or that would be easier than converting inches and calling it 1/12 of a foot, but we could do that also. But let's call 5 feet, we would convert that to 5 feet, as we know, there's 12 inches in a foot, so 5 times 12, 1 to 60. So that's the ratio. So our scale factor from the smaller one to the larger one to the actual size building is 1 to 60. So that is going to be our ratio. So the scale factor is 60. We just saw that. Just be careful because it's 2 different units. We have to convert them both to be the same. Either both to inches or both to feet. We just did inches because that would be a little bit easier. The surface area of the building is how many times the surface area of the model. And if it's 60, okay, and then we're talking about surface area, so our scale factor is 60, so we got to get A correct in order to get B. So we do 60 squared because we do 60 to the power of 2, it's 3,600. So the total surface area is going to be 3,600 times that of the original. And then the volume, well, still a scale factor of 60. We're looking at volume, so it's our scale factor to the power of 3. 60, 60 to the power of 3, and we get 216,000. So the dimensions are 1 to 60, so scale factor of 60. That means if we're looking at a perimeter or height or something one-dimensional, it would be 60 times greater. Any area, surface area, lateral surface area is going to be 3,600 times greater. And then when we talk about volume, it's going to be 216,000 times greater. Example 2, to create a cast bronze sculpture, the ancient artist carved the subject in beeswax. Then the wax was covered in liquid clay and heated. And the cast was heated, the clay hardened, and the wax melted away. Melted bronze was then poured into the hardened clay mold. When the metal cooled, the clay was removed, leaving a durable bronze figure. The artist was commissioned to create a similar solid bronze figure 10 times larger than the original. How many times as much bronze would be needed? So again, our scale factor, we just had it, what was it? It's going to be 10 times, so that's a scale factor of 10. So if I scale factor, I was just use SF, is 10, and we need to know how much bronze. Again, it's solid, it's three-dimensional, so we're talking about capacity or volume. So it's going to be our scale factor to the power of 3, or 10 to the power of 3 equals 1,000. So we need 1,000 times as much bronze for a statue that is 10 times bigger, has 10 times the dimensions. Okay, practice set we'll go over together. All right, lesson 109, we're looking at consumer interest. So interest we've talked a little bit about. We know if it's something we have to pay back, auto loan or a home loan or something like that, we want lower interest. When it's our money that we're investing or saving or whatever the case may be, we want higher interest. So if we're paying back, we want, if it's money that we're investing or saving, we want higher interest rate. That means our money is going to grow faster. So borrowing money is kind of inevitable. There are some people that are fortunate enough to pay cash or have enough money on hand to go buy a car or a home or whatever and not have to take out a loan. But most people in a lot of situations for bigger purchases in life are going to have to take out a loan. So they pay back that amount over time and they end up paying more. Because the people that give out these loans, they need to have a reason to do it, so they're incentivized by over time they're going to make more money on that loan than it originally was for. So looking at some different examples, a mortgage, the money borrowed to buy a home is called a mortgage. Again, it could be over 10 years, 15, 30 years, it just depends on the type of loan. If a person borrows $300,000 at 7%, fixed interest rate. Fixed just means that it's not going to change year to year. There is a variable interest rate where if rates go up or down, those type of loans will kind of mirror that increase or decrease. But fixed means you get locked in at that for whatever the term may be, in this case for 30 years. Borrower makes equal monthly payments of about $2,000 monthly payment, current interest, and small amount of the $300,000 principal. If the borrower continues to make the mortgage payment for 30 years, 316 monthly payments, 12 months in a year over 30 years. Until the loan is repaid, the sum of the payments will be $720,000. So that pays off the original $300,000, but then $420,000 in finance charges or interest. You can see where that's where banks or these lending institutions, they're making a lot of their money off of that being paid back. They're not going to loan $300,000 with no interest because they're taking on all the risk and there's no reward. 15-year loan repays the original loan in half the time and may lower the interest rate, so the total finance charge is less. However, the monthly payments on a 15-year loan are higher, not twice as high, but perhaps a third higher. So that's where down the road when you're ready to buy a home, you kind of look at the different, and there's different types of loans depending on what you're purchasing, like land or how much money you have to put down. It would affect the type of loan you get and those things. So it may make more sense to do the shorter term. It's going to be more each month, but you're paying it back for 30 years, you're paying it back for 15 years. Also, what's a lot of people will do is, even if they're in a 30-year loan, most of these loans, as of right now, the laws don't have any sort of prepayment penalty, so people will pay an extra 100 or 200 or 300 or whatever dollars a month, and that goes directly towards the interest, so they're able to pay it off quicker than maybe the 30 years. But anyways, you guys are learning a lot about mortgages and stuff down the road. But it's important to understand, because I mean, you end up paying $720,000 for a $300,000 home. Now that's over 30 years, granted, but still, it's important to understand what those rates mean. And there's other things that there's principal, interest, obviously, and then there's taxes, like property taxes and insurance and things like that that go along with it. So again, the payment may be even a little bit higher than just principal and interest. Auto loans, again, those are usually shorter, 36 months, 60 months. I think there's some dealerships and banks that will do 72 months. Or the longer you spread it out, the payment's going to go down. The quicker you can pay it off, obviously, the less you're going to pay in the long run. So it just kind of depends. If someone can't afford that much monthly right now, they'll probably spread it out. Or if someone can afford it and they just want to get it knocked out, they're probably going to take the shorter loan. APR, you've probably seen that a lot. That's just the annual percentage rate. There's the interest paid, the percentage that you're at, the term, the length of the loan, and different things like that. Credit card, another thing, you're paying for a service. So you take something out on credit, you're going to pay it back, but more than likely you're going to end up paying more than you originally did. If you make a payment and pay off your total balance every month, that's great. You're not going to have interest that builds on top of it. The whole thing of credit scores and things like that, where it may be beneficial to keep some revolving credit, just because it'll help increase your credit score and things like that. But more than likely, most people, like most Americans, they use credit cards because they don't currently have the money on hand. The advantage is you can get whatever you need, gas, groceries, pay medical bills or whatever, put it on the credit card. Obviously, risk of that is you don't have the money, and you're using money you don't currently have, and that money is going to grow because of the interest rate. So let's say you take out $5,000 on a credit card, emergency situation, you have to do it. When you pay it back, you're going to end up paying more than that $5,000 that you obviously don't currently have. All right, so all that, let's get this example. Jason has a credit card balance of $1,200 a month. The card company charges 2% interest on the unpaid balance each month. What is the interest charge on Jason's current balance? Okay, so we go in here, we look at 1,200, 2%, again, we got to convert to a decimal, so 0.02, the decimal two places to the left. So 1,200 times 0.02, that's $24. So that's the interest. Again, not overwhelming, but you can imagine if that interest rate was higher, or if it was 120,000, or hopefully a credit card doesn't go that high, but 20,000 or something like that on a credit card at 4%, you can imagine how quickly that interest could add up. Jason has a choice of paying the balance plus interest in full, or making a minimum payment of $50. If Jason makes only the minimum payment each month, what balance will he carry to the next month? So he has the $1,200 plus $24 in interest, so he's now at $1,224 minus $50, so he's going to still owe $1,174. So the $50 didn't cut it to $1,150 because they had that $24 interest charge each month. If Jason makes only the minimum payment and makes an additional $800 in purchases during the next month, what will be Jason's approximate balance for the next month? Interest is applied. So we go, he did the 24, so we got that added. He paid 50. Oh, no, sorry. The zero is sticking today. So we had 1174, 1224 minus 50, and then he's making another $800 purchase. So he's now at 1974. What we're being asked to he makes only the minimum payment, so additional $800 charge what would be Jason's approximate balance after next month's interest. So still sticking at the 2%. So now we got to figure out. Okay, so it's going to be 2%. So it's going to be 102%. So just to cut out a step, I'm just going to multiply by 1.02, or $2,013.48. So again, they rounded it to about $2,000. $2,000 that he owes. And we'll go over this practice set together. And then the last one for this week is going to be lesson 110, which means we're ending this unit. We'll go over the review next week, and then we'll take the test. All right, lesson 110, converting repeating decimals to fractions. So this one is interesting, but once you get the hang of it, I don't think it's too bad. So we know repeating decimals can be 1, 2, 3, 4, however many digits that repeat infinitely. So it's non-terminating. It's not irrational. It can still be expressed as a fraction. So if we do 3 divided by 11, this is what we end up with. So 3 divided by 11. We get that repeating forever. We know like 1 divided by 3. 1/3 is 0.3 repeating forever. So we have these repeating decimals. We put the bar above it to indicate which digits are repeating infinitely. So we don't just put above the 2 or just the 7, since 2 and 7 are both repeating. We're going to put the bar above that. So how we're going to convert a repeating decimal to a fraction? We're going to do an equation. So in the book, they use F for fraction. There's a fraction out there because it's still rational. We know it's repeating. It's still rational, so we can express it as a fraction that equals this number. Okay, so we got that. Second, we're going to make an equation, and we first count the number of digits that are repeating. So there's 2 repeating digits. Then we multiply both sides by the first equation by a power of 10. So 10 to the power of 1, 2, because there's 2 repeating digits. So it kind of sounds complicated. Once we do a few, you guys will get the hang of it. So 10 squared is 100. So we have 100F equals 100 times the decimal. So again, we're just saying, well, if F equals this, then 100 times this equals 100 times that. That's all we're doing. And we got 100 because we had 2 digits that were repeating. If we had 1 digit, it would be 10 to the power of 1. If we had 4 digits, it would be 10 to the power of 4. And we set up 100 times F is just 100F. 100 times 0.27 repeating forever is 27.27 repeating forever. Okay. Now we take the second equation, so this one that we just came up with, and we subtract the first equation from it. So we had 100F equals 27.27 repeating forever minus F equals 0.27 repeating forever. And then we notice, even though these are both repeating forever, what they do is this is the same as this. So when we subtract that, it becomes 0. 27 repeating forever minus 27 repeating forever is just 0. And that's how we essentially get rid of that repeating decimal, and we'll come up with a fraction. 27 minus 0 is 27. 100F minus 1F is 99F. Now we want to figure out what F is, so we divide. We divide both sides by 99, so we get 27 divided by 99, which is 3/11ths when we reduce, because 9 goes in both of those. So let's look at this one, 0.16. Repeat. So we got the bar of it, so there's 2 repeating decimals. We need to know that. So first we're going to have, there's a fraction out there that equals 0.16 repeating forever. Okay, 1, 2, so that means we do 10 to the power of 1, 2, so 10 squared, which is 100. F equals 100. Equals 100 times 0.16. Now when we do that, Again, this is 16, 16, 16, going on forever. So when we multiply by 100, we move the decimal 2 places and we end up with 16, but then we still have this 1 and 6 that would be repeating forever. So we move the decimal 2 places, but we can move the decimal 1,000 places. It's still going to be repeating because of this bar. So that's how we're able to get that. So 100F, nothing changes over there. You can write in the 1 coefficient if you want to. You don't need to. Equals 100, that way times 0.16 repeating, so that was 16.16 repeating. You can fill in the 0 if that helps us. So 16.16 repeating forever minus 0.16 repeating forever is just 0. We got rid of it, that's good. And we have 16 minus 0 is 16. And 100F minus 1F, 99F. Okay. So 99 times a fraction equals 16. Multiplying, we need to divide. We end up with a fraction equals 16 over 99. I don't think, let's see, 4 doesn't matter. Okay, yeah, because this ends in a 9, so 3 goes into it, 9 goes into it, because 9 plus 9 is 18. The only things that go into 16 are 2, 4, 8, and 16, and none of those go into 99, so that is reduced as we can get it. What are we going on? Oh, okay. So pay attention to the bar. So we did it correctly with this number. So their example, I didn't realize was 0.16 with just the bar above the 6. So pay attention to the bar. Again, we did it the right way for this number. It ended up at 1699. So I was wondering, I was like, that seems like a pretty complex fraction to start with. But okay, their bar, I just miswrote it, was above just the 6. So we'd still do the same thing, but we'd only have one repeating decimal. So we'll do 10F equals 1.6, repeating forever, and then subtract and divide, and we get 1 over 6. Okay, let's look at this one. If we have 0.027, it's repeating forever, and we'll figure out what the fraction of it is. Let me make sure that okay, just the bar above the 7. Okay, so there is a fraction out there that equals that. And then there's one repeating decimal, so 10 to the power of 1. We're going to have 10F, 10 to the power of 1, F, or just 10F. Equals 10 times this, so we move the decimal place here. And it's going to give us zero. Move the decimal 1, 2, and 7. Repeating forever. Okay, so we got it set up. And we got the 7 repeating forever. Again, even though it goes on forever, it's still the same number minus itself, so the same will apply, just like 5 minus 5 is 0, 0.7, 7 repeating forever minus 7 repeating forever is just 0. And so the bar is over 7. We're subtracting this, it's important. 7 repeating minus 7 repeating is just 0. 7 minus 2 is 5. 2 minus 0 is 2, and 0 minus 0. But make sure, especially if you're probably be doing this by hand, so it's easier. So make sure your decimals are lined up in your tenths, hundredths, thousandths. 10 minus 1 is 9F. Both sides by 9. Nine cancels out. And since that one wasn't a really easy, we had a decimal. Can you see it? So I did 0.250. So we had 0.250 or 0.250, same thing. And then divided by 9, we got this. And then the nice thing, we can go math and then fraction, and we'll take this decimal and convert it to a fraction. Since we have a complex fraction with a decimal in the numerator, and then we could have moved the decimal over and made this 25 over 90. That's fine. We're pretty good at that. Knowing how to convert fractions in our calculator. So 1/36. And if we have 180 tries, or what was the original one? How many times would we get 12 and 180 rolls? So we do 1 in 36 times 180, except that a bit. Happening 180 times, we'd expect to get 5. So we can expect to roll 12 5 different times. So the hardest part was finding this fraction. Once we had that, then we just multiplied it by 180 to get 5. All right, we'll go over those practice set problems together, and that will be all for this unit.